this will match up with your 5.2a assignment. And we are starting right triangle trig. 5.2 will be split up in a lot of sections. But this is just our preliminary start. So first things first, let's label a right triangle. So for any right triangle, this is my right angle. We know that's my right angle because it's got that fun little square in it. We can label the angles of our the angles, the corners, we label them with capital letters. So we are going to label this lower left corner with capital A, this upper right corner with capital B, and we're going to label our right angle with capital C. When we are labeling triangles, we labeled our sides with the same letter as the corner they're opposite, but lowercase. So this is capital A, so this side over here is little a. This is capital B, so this side down here is little b. This is capital C, so this side over here is little c. Okay. We can also label our sides, so we will both use A, B, and C to refer to our sides. We are usually going to be finding our trig functions of our angle A. So we are going to go ahead and label our angle A with a theta. So the Greek letter theta, a capital theta is a capital O with a line through it. That's a lowercase theta?
I said, what's a lowercase theta?
Oh, they actually look super similar. Wait, theta. They're the same. I didn't know that. Yeah. Basically the same. Okay. Yeah, one, I don't know why. Like, one's like, I'm going to italicize myself. Anyhow, so we will use theta. We'll use other Greek letters to reference our angles, but for the most part, and for today, we're using theta, I think, the entire time. Okay. In reference to theta, side A would be the opposite side. Meaning it's opposite, across from it. Side B is our adjacent side, meaning it's attached. And side C is our good old hypotenuse. So, go ahead and get that little triangle labeled with both A, B, and C, and opposite, adjacent, and hypotenuse, because we are going to use both of those interchangeably. Okay. So, any questions about this triangle before we start talking about our 6 trig functions? Our 6 trig functions. Any questions about this triangle? These triangles? Yes.
You know how last semester we got to earn our table do that?
Yeah.
Are we going to earn our table do that?
Possibly. Let's see how we do this first unit. Okay, so next thing that we are going to talk about is our 6 trig functions. When I write my 6 trig functions, I like to write them in the following order. I like to write them in two columns. I like to write sine, cosine, tangent, and then cotangent, secant, cosecant. That's what I'm going to do here because that makes them match up really nicely. And that's also the order that they usually, there's two orders they get asked to you in. That's the order that I'm going to give them to you right now. So the first of our trig functions is sine. Spelled S-I-N-E, it is pronounced sine. Its abbreviation is S-I-N. Every trig function has a 3-letter abbreviation. Sine of theta is equal to the opposite over the adjacent. So I'm going to write op over ADJ. I'm abbreviating things. Which can also be referred to as A over B. These are our 6 basic trig functions. What they will let us do is in the future, when we don't know all of our side lengths or all of our angles, they let us find the unknown side lengths and side angles. So if we know either 2 side lengths, we can find the angle. If we know 1 angle and 1 side length, we can find the other side length.
So if we want to go for side, we put side length.
Yes. Just no. You're going to have to hold on. Theta is the angle, A and B are the side lengths. Today we will be plugging in the side lengths. Please put your mask over your nose. Okay, next trig function is cosine. Cosine is spelled C-O-S-I-N-E. It's pronounced cosine. Its abbreviation is C-O-S. Cosine of theta is equal to adjacent over hypotenuse. You guys, I wrote down sine wrong, didn't I? Thank you. Everybody rewind. I completely messed up the most basic part of trig. Sine is opposite over hypotenuse. It's A over C. Go back. Everyone right now. Sine is opposite over hypotenuse. I want to delete this recording, but I won't.
They'll edit it. Yeah, you could edit a recording, right?
I mean, I could clip it out, but then it would just be really confusing and choppy. Sorry, recording. Sorry, everyone.
It's okay.
Thanks for noticing.
It's not okay.
Okay, cosine is our adjacent over our hypotenuse. So that's going to be B over C. So sine, cosine, tangent. Tangent abbreviation is TAN. Tangent of theta is our opposite over our adjacent, which using letters would be A over B. Okay, so we've got sine, cosine, and tangent. Any questions right now? Make sure you fixed my righto, which is a typo when you're writing. Make sure you fix my righto on sine. Opposite over hypotenuse, adjacent over hypotenuse, tangent, or opposite over adjacent. Okay, how do we remember sine, cosine, and tangent? SOHCAHTOA. So, SOHCAHTOA is an easy way to remember sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. SOHCAHTOA. That's a way to remember those 3 functions if you need it.
So yeah, I've never used it for like a year.
Okay. Any questions right now?
Don't move on yet.
Okay. Give you a second. You need something else to write with, or are you good? Okay. So, sine, cosine, tangent. Those are the three trig functions. Did you guys do cotangent, secant, and cosecant in geometry? Yeah, okay. Okay, we have three more trig functions. Cotangent is the reciprocal of tangent. So I'm going to write it right here. Cotangent's abbreviation is COT. Cot. Cotangent of theta is the reciprocal of tangent of theta. So instead of opposite over adjacent, it's adjacent over opposite, which would be B over A. The reciprocal of cosine is secant. Secant. Secant's abbreviation is SEC. And since it's the reciprocal of cosine, secant is our hypotenuse over adjacent, which would be C over B. And then finally, the reciprocal of sine is cosecant. So COSECANT. Cosecant's abbreviation, it's the only one where it's not just the first three letters, because cosine is already COC. So cosecant's abbreviation is CSC. Cosecant of theta is our hypotenuse over our adjacent, which is C over A.
Isn't it opposite?
Yes. I just can't do sine and cosecant, apparently. Thank you. Still C over A, though. Sorry, video. Dale, clip that out, too. I'm just going to upload this straight to YouTube anyway. I'm not actually going to edit it. Okay, so sine, cosine, and tangent, cotangent, secant, and cosecant. So there are two orders that people will ask you these, and people will read them. I always read them in that order, and that's why I go down and then back up when I'm like thinking about it. That's how I do it on paper. It's sine, cosine, tangent, cotangent, secant, cosecant. But the reason why I go down, I don't just do two columns, is because then they won't be with their reciprocals. Right now, if you want to draw some sideways arrows to remind yourself that these are reciprocals, that might be a fun idea. You are on Math Excel. I did it before this so that I could know. Your questions will be asked sine, cosine, tangent, and then cosecant, secant, cotangent. What's up?
Is there any like fancy abbreviations for the secant, cosecant, and cotangent?
No. Here's how to do it. No SOHCAHTOA, sine, cosine, tangent, and then know that cotangent, secant, cosecant, if you go down and then back up, are just the reciprocals. And on your assignment, you will answer sine, cosine, tangent. Then for cosecant, just go look at the answer for sine, flip it upside down. Go look at the answer for secant, flip it upside down. Go look at the answer for cotangent, flip it upside down. Work smarter, not harder in life. Okay, any questions right now? We're going to go use this for just some basic examples now. Okay, so I'm going to go ahead and move this sheet of paper. The first triangle, we're going to do 2 full examples today, just so you've got 2 examples. The first triangle that we are going to do, this right triangle, A, B, C, we are given that side length A is 5, and that side length B is 12. So A is 5, B is 12. We do not know what side length C is. How, friends, can we find what side length C is? How do you find the hypotenuse of a right triangle? Pythagorean Theorem. A squared plus B squared equals C squared. So, Pythagorean Theorem, A squared plus B squared equals C squared. What? Okay, Pythagorean Theorem. It's how you find the missing side length of a right triangle. A squared plus B squared equals C squared. A squared would be 5 squared, so that would be 25. B squared would be 12 squared, so that would be 144. $25 plus 144 is 169. So 169 equals C squared. And then the square root of 169 is 13, so that means C equals 13. Or, if you remembered some of your common right triangle Pythagorean triples, you could have been like, that's a 5, 12, 13. So we now know that C equals 13. Any questions right now on finding that missing side length? I was so far zoomed out. Okay, so then the next thing that we are asked to do is we are asked to find the 6 trig functions of theta, which is angle A in this triangle. So we want to find sine, cosine, tangent, cotangent, secant, and cosecant of theta. So sine of theta, cosine of theta, and tangent of theta is what we'll do first. You can use our words opposite and adjacent and hypotenuse, or you can use A, B, and C. Sine of theta is opposite over hypotenuse, so of SOHCAHTOA. So sine of theta is 5 over 13. If we could reduce that fraction, we would want to. We can't. Next is cosine. Cosine is our adjacent over hypotenuse. Cosine is going to be 12 over 13. Can we reduce 12 over 13? Negatory. Okay, last one. Tangent, or TOA, is opposite over adjacent. Opposite over adjacent would be 5 over 12. Okay. Oh, that's not what I wanted to do. I wanted to move this. Does that not move? I didn't know that move, though. That's kind of spooky. Cool. Okay. Any questions about sine, cosine, or tangent? You might be like, oh, we're only halfway done. This is so much more work. It's not. The next three things you will be asked are for your cosecant, your secant, and your cotangent. You already did all the work. You've just got to know who is the reciprocal of who. Cosecant is the reciprocal of sine. So your cosecant is 13 over 5. Secant is the reciprocal of cosine. So your secant is 13 over 12. Cotangent is the reciprocal of tangent. So your cotangent is 12 over 5. And that's it for those last three. Once you've done sine, cosine, and tangent, you just have to know who to flip. Okay. Any questions about those six things? Each question is going to be 7 parts on Math Excel, and there's 4 of them. You have to answer question 1, 2, 3, 4, 5, 6, 7. Those are the 7 parts, and that's the order they go in. Okay. Let me pick one more triangle to do. The one I had written down from last year involved rationalizing denominators, which is not something I want to do right now because, ew. So let me pick, we're going to rationalize denominators tomorrow. Let's just do a nice iteration of a 3, 4, 5. Okay, let's do one more triangle. Here's what we know about this triangle. We know, and I'm going to draw this triangle the opposite direction. Crazy. This is going to be my angle A. This is going to be my angle B. This is my angle C, which is my right angle. We are again going to be finding all of our trig functions of angle A. And what we know about this triangle is we know that our hypotenuse, our C, has a length of 10. And we know that our opposite side, our A, has a length of 8. So we need to figure out our adjacent before we can find our trig functions. So this time, when we do Pythagorean Theorem, for a squared plus b squared equals c squared, we know a and c. We have to solve for b. So a squared plus b squared equals c squared. A squared is 8 squared. B squared is what we're solving for. And c squared is 10 squared. So we've got 64, because that's 8 times 8, plus b squared equals 100. We can subtract 100 from each side, or subtract 64 from each side, sorry, and figure out that b squared equals 36. If b squared equals 36, what's the side length of b? 6. Yep. So b equals 6. Okay. So sine, cosine, and tangent. I'm just going to write sine, cosine, and tangent. I'm not going to write the same opposite of or adjacent. All that shenanigans because you have it right above. And it's SOHCAHTOA, you can remember. So SOHCAHTOA, opposite over hypotenuse. What is the sine of theta? I'm rhetorically asking you this time. What is our sine? What's our opposite? 8. What's our hypotenuse? 10. 8 over 10. What does 8 over 10 reduce to? 4 over 5. Awesome. Okay. Cosine of theta. Somebody other than Alder. What is our adjacent side? 6. What's our hypotenuse again? 10. So 6 over 10. That reduces to 3/5. And then tangent of theta is opposite over adjacent. We already know that our opposite's 8 and our adjacent is 6. So that's going to be 8 over 6, which is 4/3. Okay. Then we're going to do cosecant, secant, and cotangent. You guys already reduced these, so don't unreduce them. Like, why would you do that? Cosecant is 5/4. Secant is 5/3. And finishing us out, tangent is 3/4. Okay, any questions right now? Go get started on today's assignment. Then tomorrow we're going to do some like common angles, like 45 and 30 degree angles, or like 45, 90 triangles and 30, 60, 90 triangles. But for today, that's it. Bye, recording. Sorry I messed up twice.